Salmon aquaculture is already a high-tech industry, but aeration is one area which has not changed in a long time. And through the Airlectric Project, we've taken a massive leap forward. In salmon farming, it's essential to maintain good water quality and in particular, high levels of oxygenation. The Airlectric Project started when Numa International approached us at Stirling University and told us they'd developed this prototype aeration system. So it was innovative because it's electric powered, so it's basically plug and play, fits the side of a net pen. But the main innovation is it's smart controlled, so it can respond to low water quality events such as low oxygen levels or also high plankton loads. So they developed this prototype and they wanted us to test it scientifically and see how it compared to traditional aeration systems, but also what impact it had on fish welfare and performance.
Within the project, we use life cycle assessment to better understand the environmental performance improvements that a smart aeration system can achieve compared to standard diesel aeration.
We had an array of water quality sensors in the water, dissolved oxygen sensors, we had salinity sensors and chlorophyll sensors which measured plankton levels. And these collected data every few minutes and then sent that data back to a central hub. For this trial to work, we needed to get that hub connected to the internet. Of course, in rural Scotland, the mobile network's not always that good. So we tried different mobile networks. We tried to connect to the site Wi-Fi, but it wasn't within range of the hub. And eventually we had to set up our own Wi-Fi router in a nearby feed container and get that data beaming up to the clouds. And once we'd achieved that, then we could use that to trigger the smart aeration on or off.
So when we compare both systems, we can clearly see that the smart aeration systems can achieve cost reductions up to 75%. Greenhouse gas emissions, we can achieve reductions over 90%.
One of the benefits of the smart aeration system is not just the reduction in environmental impact, but also the improved benefit in fish welfare. So we had a master's student who was looking at this for a research project. Measuring cortisol in his scales measures long-term chronic stress. And what she found was actually there wasn't a significant difference between the stress levels of the two treatments. But actually that wasn't bad news, because what we can say now is that using the smart aeration, we can reduce the environmental impact and improve efficiency of aeration in salmon aquaculture, but without impacting fish welfare.
Smart aeration should be part of a broader sustainability toolkit that the industry can utilize to boost economic and environmental performance of the industry.
So one thing we'd like to try next is coupling the smart aeration with oxygen forecasting. If we could predict when there's going to be low oxygen events, then we can use that to trigger the smart aeration system. And that's going to improve fish welfare and performance even further and bring modern aeration into this realm of precision aquaculture.